In this lesson, we're going to look at the periodic table and then look more at how things are arranged within it and things that we can predict based on their locations. When we look at the periodic table, the first thing you might notice are the chemical symbols, and these are simply abbreviations for each chemical name. When we look at the symbol, there's a few things we need to make a note of. The first, or if it's the only letter, is always capitalized. The second letter, if it's present, is never capitalized. So if we look at hydrogen, its symbol is H, one letter, capitalized. Helium, capital H, lowercase e. Sodium, capital N, lowercase a. Chemical formulas use those chemical symbols to show us how those atoms are combined to form compounds. So it shows us both the type and the number of those elements. For example, if I looked at H2O, that tells me that in every molecule of H2O, I have 2 hydrogen atoms and 1 oxygen atom. When I look at magnesium nitrate, the 2 outside the parentheses tells me that I have 2 NO3 groups. So we have 1 magnesium because there's no subscript with the magnesium, so it's assumed to be 1, and 2 NO3 groups. Each NO3 group contains 1 nitrogen and 3 oxygens. Therefore, if I have 2 NO3 groups, I have 2 nitrogens and 6 oxygens. When we're looking at formulas, capitalization matters a lot. CO with a lowercase o is the element cobalt. Capital C, capital O is the compound carbon monoxide. You need to pay attention when you're writing symbols to make sure you mean what you're writing. How many hydrogen atoms are in one molecule of C3H7OH? Notice that hydrogen is present in 2 different places in the formula. This has to do with how those atoms are connected in the molecule. And we're not going to worry about that right now. All we need to worry about is that we count all of the hydrogens. So we have 7 hydrogens first, then we have 1 more hydrogen because there's no subscript, so we have a total of 8 hydrogens in this molecule. How many oxygen atoms in 1 unit of aluminum sulfate? Each sulfate has 4 oxygen atoms, and there are 3 sulfate or SO4 groups. Therefore, we have 12 oxygen atoms in 1 unit of aluminum sulfate. Which one correctly pairs the element and its symbol? N is the symbol for nitrogen. When we look back at the other examples, we see S stands for sulfur, Na is the symbol for sodium, Ca is the symbol for calcium, carbon has the symbol C, K stands for potassium, and Kr is krypton. Note that there are some elements that you need to know the names and symbols of. If you look in the concepts to memorize, you'll find a periodic table that's shaded to show which ones you need to know. You do not need to memorize the numerical values, only the names and symbols of the shaded elements. Let's look more at the periodic table and how things are arranged. The first thing is to talk about how we describe the periodic table. Each row is called a period. So we have the first, second, third, fourth, and so on periods for each row in the periodic table. The columns are known as groups or families, and this is because they have similar chemical properties. So when we start to look at elements, those that are in the same column will behave more similarly than those in different columns. An exception to this is hydrogen. It's kind of an outlier. It's over on the left side, but it's not, doesn't really belong there. It doesn't really fit in anywhere. So it kind of gets stuck there. So when we talk about the properties of that first column, we're talking about everything from lithium, Li, on down, and not including hydrogen in that. You'll notice there's 2 sets of numbers on the periodic table as well, which are the group numbers. The modern system uses the nomenclature or the labeling of 1 through 18 from left to right. The older system uses 1 to 8 with A and B included in that. The first thing we want to look at is a division of the elements into metals, metalloids, and nonmetals. Notice that the vast majority of elements on the periodic table are metals. These are on the left side of the periodic table. On the right side are the nonmetals, and in between those are metalloids. So these are species that have properties similar to both metals and nonmetals. A few of the group names that you'll hear quite often are Group 1, which are the alkali metals. This does not include hydrogen. Group 2, which are the alkaline earth metals. Group 17, which are the halogens, so fluorine, chlorine, bromine, iodine. And then group 18 are the noble gases. So these are very unreactive elements. We see the coinage metals. It's not an expression we use a lot of. You might also occasionally see something called chalcogens, which is group 16 in the periodic table. Which pair of elements will have the most similar properties? Let's first locate each element on the periodic table. So we have lithium and beryllium. They're in the same period, but different groups or different families. We have sodium and chlorine, which are on opposite sides of the periodic table. So one's a metal and a nonmetal. We have nitrogen and phosphorus, which are in the same family. And then we have boron and silicon, which are both metalloids, but in different families. So of these four pairs, nitrogen and phosphorus are going to be the most similar because they're in the same family. We also sometimes refer to different blocks of the periodic table. So we see in the left and the right, groups 1 and 2 and 13 through 18 are called the main group elements. These are the elements whose behavior is most predictable, and we'll spend most of our time talking about these. We'll hit on a few of the transition elements, but most of the chemistry we'll look at is involving the main group elements. In the middle, we see our transition elements. These are all metals, and their behavior is just a little less predictable than our main group elements. The inner transition elements are down at the bottom. The lanthanoids and actinoids are ones we don't see very often. Many of these are synthetic elements, but also they're not present in very large amounts on Earth. Which ones are transition metals? Choose all that apply. So we have sodium, iron, calcium, palladium, and krypton. Iron and palladium are our two transition elements. The rest of the elements are considered main group elements. We talked about metals, nonmetals, and metalloids, and what we see is a gradual transition. So as we go from left to right, the elements on the left have very metallic behavior, and it slowly decreases as we go right until we get to the metalloids, which kind of have a mixed behavior between metals and nonmetals. And then we get to the right where we see our nonmetals. And some of the properties we see in a metal are that they're shiny, they're malleable, which means we can change them into a new shape, we can bend them. Ductile, so we can draw them into a thin wire. So think about something like copper, which you can form wires from. They're also excellent conductors of heat and electricity. Nonmetals, including hydrogen, so hydrogen's a nonmetal, even though it's on the left side of the periodic table, are very brittle when they are solids. And metalloids are kind of a happy medium between the two of those things. All of these properties happen on a spectrum, a gradual change from one to the other. We don't see a hard and fast line where something is a metal and then a nonmetal, hence the metalloids, which are more in that transitional area. What is the halogen in the third period? If I look for the halogen, I know this is group 17, those are known as my halogens. And then I look at the third period. So I go down to the third row of the periodic table. When I look at the intersection of those two, I see that chlorine is the halogen in the third period.